Hello, and welcome back to another speedrun with me, Vince, of the IB Math textbook. So today we're going to be finishing off Chapter 3 by completing Chapter 3.6. And yeah, let's jump right in. So Chapter 3 is all about linear systems of linear equations, and we need to know how to solve them. So the first step is we need to know how to solve systems of linear equations when there are only two equations and two unknowns. So something like this would be a valid system. As you can see, we have two equations and we have two unknowns here. So the rule of thumb is you actually need to have at least one equation per unknown to be able to solve the system. Okay, so we need to talk about this because there are three possible results for attempting to solve this system. So the first result is that there's a unique pair. And if there's a unique pair, that means that there's like exactly one pair of numbers that satisfies this equation. And so the lines, if we graph them, mean that there will be one intersection between the two, which is at the coordinates of the pair. So the second case is that there's no solution. And so this means that no matter what values of x or y we put in, we won't get a solution. And this means that the two lines of the linear equations are parallel and distinct, so they never touch each other. The third result is that there are infinitely many solutions. And this occurs if and only if the two equations are more or less equal to each other, and so their lines coincide. So for all values of y, there will be at least one value of x that satisfies the equation, and so it's true for all values of y. And there are infinitely many pairs. Yeah, that's it. So now we can jump into some questions. So the first question is asking us for this system, mx plus 6y is equal to -2, and 7x plus 3y is equal to 5. Find a value of m such that this system has no solutions. And remember, if this system has no solutions, it means that the lines must be parallel and distinct. How do we make these lines parallel? Well, they must have the same gradient. So if we rearrange this, we can technically do it faster, but this would be y is equal to -7/3x plus 5/3. So we need to make this line have the same gradient, -7/3. Well, let's rearrange this. Y is equal to -m/6x minus 2. So we need to make m such that -m/6 is -7/3. So therefore, m must equal 14. Pretty easy. Okay, on to the next question. The next question asks us for the system 6x plus py is equal to 8 and 3x plus y is equal to 4 to find a value of p, so there are infinitely many solutions. For there to be infinitely many solutions, the two equations must more or less be equal to each other. We can look at these two coefficients of x that they're separated by a multiple of 2, and these two coefficients that they are also separated by a multiple of 2. So if we divide this top equation by 2, we get 3x plus p/2y is equal to 4. So for these two equations to be equivalent, p/2 must be equal to 1, so p must be equal to 2. Pretty easy. Okay, on to the next question. And the next question is asking us for this system, 2x minus sy is equal to 1. And 3x minus y is equal to 2. We need to find the values of the parameter s for which the system has a unique solution and find the solution in terms of s. So the first thing I'd like to do is rewrite these two equations so that they're in the form y equals mx plus c. So this would be y is equal to 2/s times x minus 1/s, and this bottom one would be y is equal to 3x minus 2. So what can we tell from this? Well, we can tell that first of all, s cannot be equal to 0. because we're dividing by s and we can't divide by 0. The second thing we can tell is that s cannot be equal to 3 over 2. If s was equal to 3 over 2, it would make the gradient of this line have the same gradient of this line. And because we're looking for values of s, so the equation only has one unique solution, the gradients cannot be the same. So s cannot be equal to 3 over 2, but other than that, s can be equal to any of the real numbers. Finally, it's asking us to express the solution in terms of x. And that's pretty simple. Let's equate these two equations. So we have 3x plus minus 2 is equal to 2 over s minus 1 over s, 2 over sx. And let's multiply both sides by s. So we have the 3sx minus 2s is equal to 2x minus 1. And so we can bring all the x terms to one side. So we have x times 3s minus 2 is equal to 2s minus 1. And so we have x is equal to 2s minus 1 over 3s minus 2. So that is the first part. Now we need to solve for y in terms of s, and we can do that by substituting this back into one of the original equations. So we know that y is equal to 3x minus, is it minus or plus? Minus 2. So we have this equal to 3 times 2s minus 1 over 3s minus 2 minus 2. So if we expand this, this is equal to 6s minus 3, and then let's put this into the fraction. So that would be minus 6s plus 4 over 3s minus 2. And if we can cancel these out, we are left with 1 over 3s minus 2. So this y will be equal to 1 over 3s minus 2, and x will be equal to 2s minus 1 over 3s minus 2. So those are our solutions. Okay, on to the final problem. So we have a system of a times x plus y plus b times x minus y is equal to 1. And we have a times x minus y plus b times x plus y must be equal to 1. And we need to find the solution in terms of a and b. And a and b, so a and b are real numbers, and they are not equal to 0. We need to find the solution in terms of a and b. So let's, I guess we have to multiply these two equations out. Actually, there's a bit of a trick here because they're both equal to 1. To satisfy both equations, we can just set them as equal to each other. So a times x minus y plus b times x plus y must equal a times x plus y times plus b times x minus y. So what we have here is we have a minus b times x minus y is equal to a minus b times x plus y. So a and b are not equal to 0. So where do we go from here? I'm just wondering, because I think this might be a bit more complicated than it looks. Okay, because the thing is, let's divide both sides by a and b. So we have x minus y is equal to x plus y. So the only solution for this, if we cancel out the x's, is that 2y is equal to 0 or y is equal to 0. So we know that, and now we can substitute it back into one of the original equations. So we have a times x plus b times x is equal. So we have a plus b is equal to 1, since a times x plus b times x is equal to 1. Oh, sorry, I meant a times x plus b times x. A times x plus b times x is equal to 1. And so therefore, if we factor this out, x equals 1 over a plus b. So that is our expression in terms of a and b, and of course y has to be 0 for this to be true. And yeah, so that's all for the speedrun. I hope you enjoyed it, and I hope you've learned a bit more about solving systems of linear equations, and I hope to see you in the next speedrun. See you then!